asked the question doesn't change physically what the bus does. Now you're saying the bus only comes from 1 to 11.5 minutes. No, it's always going to come between 0 and 15. You can't change that. But within it, you're going to find this. So if you redraw this picture, you maybe even make yours look more like a rectangle. And you put on there 1 to 11.5. You're going to find the area of that. And that's the answer. So anytime, so what do you get? So you get, what's the width? 10.5 times the height, 1/15, and then whatever the hell that is. Say again? 0.7?
Just 0.7.
0.7? Neat. All right. Yeah, 70% chance. I really want you to understand that this is not just like cheating or something. It's a step called normalizing something. So, how do I say this? So do you guys, before I wrote that, do you agree with me that this accurately represents this situation visually? Everything has the same likelihood. So this number in reality could be almost anything, but if I can make this situation so the area, total area is 1, then any question about a piece of it is just finding the area. So what does this have to be to make the area 1? 1/15. So if this was, so if I had a uniform probability, let's do another example with a different setup. So say I had a uniform probability from, this is the way the book is going to use it, 11 to 18. Take a minute and see if you can draw that. Figure out what the height is. Have to be careful. The first one I do has a 0 in it, but that sets up kind of incorrect expectations. This height is not 1/18. You with me? Some people think that because that was 1/15, but that's just because that's 0. I'm sorry, go ahead. So it looks like this. So how wide is that rectangle? 7. So what's the height gonna have to be? Yes. So as a teacher, I've got to be careful with the examples I show you because you can make incorrect assumptions and put the 18 there. But why was that 15? Because the width is 15. The width here is 7. That's got to be 1/7. And then I can ask you, what's the probability that it's between 12 and 17? What's the area of that blue box? That's all it becomes. So what's the width of that blue box? What's the height? Yeah, so it'll be 5 seconds. Which is like 0.62 something. I don't know, just spitball. Nobody wants to help me answer.
4714.
Oh shit, I was way off. Why was I so off? Oh, I'm stupid. 7 who?
714.
Must be more.
Oh yeah, 28.
Okay. All right, now let me ask you, now any question I ask you like that should be easy. It is just finding areas of rectangles. You just have to draw things correctly. What about this question? The answer is always the area of what I am asking for, right? So what's weird about x equals 15? What's the area of that line? No. What's the width of that line? 0, thank you. So what's the area? 0. I really want you to, really want this to make sense. Is anybody in the world exactly 5 foot tall?
Yeah.
Remember, no, hell no.
Oh.
Find that person, you're wrong. I really want this. If I said pick a random number from 0 to 1, how many numbers are there between 0 and 1? Infinite. So what's the likelihood you pick any single number? 0. Now, you guys semi with me? Because what's the total number of numbers? Infinity. What's anything divided by infinity? Do you guys know? Something divided by the biggest number is the smallest, is 0. Right? I know what you're talking about. You're talking about like limits and shit. I like that. Say with me. Come on. This is one of the coolest things. Officially, the answer to that is 0 because there's an infinite number of things that could happen. The only things that have non-zero answers have to be regions. How many numbers are between 12 and 17? There are an infinite number of numbers in there, right? But I don't have to consider that. I can just find the area because 17 minus 12 takes care of the range of all those infinite numbers. You're kind of with me. So don't freak out. Infinity's not going to come creeping in here somewhere. But when I ask you for a continuous distribution, what's the probability it's exactly something that is essentially 0? You don't have to know this next piece, but it's really cool. It's not really 0. It's something called iota, which is like the reciprocal of infinity. What does infinity mean? What does infinity mean?
Infinite amount of numbers.
Okay, I like it. It's not really a location itself. It's not a number. Infinity is not a number, right? Because then infinity plus 1 would mean something, and it doesn't. Infinity is a process. You just keep getting bigger and bigger and don't stop. Ain't no party like an infinity party. So the reverse of that would be the number that keeps getting smaller and smaller, but it never gets to 0. That's the idea of iota. Right? Has anybody ever heard of iota? Not iota bank, but IOTA is an equal. But I'm sorry. So again, the whole thing about iota, you don't have to worry about it. I just like to bring it up in case anybody's curious. It can't be 0 really, because if I add 0 to itself, I don't care how many times, it's going to be 0. So each one has like just above 0, the smallest positive number. But for us, we're going to call it freaking 0. So whenever I ask you for a continuous distribution, what's probably x equals something, it's 0. Because what could it be? An infinite number of things. So the probability of any one specific thing is essentially 0. Because I could say what's probably x equals 15.0100100001000100010001, and that has to have a probability, and then so does this, and then so does this, and you can change any of these, and I'm just talking about 15. There's also 14 and 13. Do you guys kind of follow what I'm trying to say here a little bit? So in a continuous distribution, the probability of anything specific is 0. And the most basic, just to come back to what I said at the very beginning, this is the only way I have to look at this. The answer is always the area. A line ain't got no area. So the answer's got to be 0. That's the only thing you have to be able to look at this as. And that is definitely enough. And what about this question? You know it's going to be weird. Maybe not weird. Let's see if you guys can. Can that happen? For this problem, what are the only values that could happen? 11 up to 18. So let's probably get something more than 18. It's like me saying you roll a normal die, what's the probably get more than 6? If you roll a normal die, it's probably get more than 6. It ain't gonna happen. It's outside the realm of things that could happen, so that's gonna be 0. What's the probability that x is more than 11? Oh shit, Jeff. I understand why you say that, but again, The probability that x is more than 11. If I pick any number from 11 to 18, what's the probability that number is more than 11? Is there any way it's not going to be more than 11? No. That's a 100% chance. I live in here, so I've got to be. That's a 100% chance. Okay, like probably x more than 18 is 0, probably x is less than 18 is 100%. Maybe. Yes? Here's the neat thing. This question is the same. Because any specific number has a probability of what?
0.
0. So if I go back and change this to be this, same answer. Because I didn't take anything away. Any specific number has a probability of 0.
Let's say that 11 was like 12 or 13, it's still 100%?
No. So, what do you mean? If I say what's probably x is greater than 12?
Yeah.
All right, now that's not 100%. Because what did I just skip? I just skipped everything from 11 to 12.
So is it 9?
What's the width I'm talking about now? 6. What's the height?
7.
So 6/7. X greater than 11, I didn't exclude anybody. That's why it's 100%. X greater than 12, I excluded these guys. It's going to be less than 100%. Kick ass. Let's take a break. All right. Come back. Is that all right? You guys want to take a break? And then we'll do some problems related to this. Come back at 10:30.